Welcome to DEMOPHYSICS. And the topic is about pressure. Our objectives: to know how does the pressure being done, to discuss how does change in force and area affects the pressure, to define Pascal's law, to discuss how Pascal's law is being done and how it is applied to real-life situations, and to solve problems involving pressure and Pascal's law. So what is pressure? Pressure is defined as the force over a given area. The standard unit of measure for pressure is the Pascal, which is abbreviated as PA. It is also the Newton per square meter, kilogram meter per second squared, all over meter squared, and kilogram per meter second squared. In the following video, you will see the differences in pressure. The surface area of the knife in contact with the apple is less, hence the pressure is high. The surface area of the knife in contact with the apple is more, hence the pressure is low. When the force is less, the pressure is low. When the force is more, the pressure is high. The less area, the more pressure. The more area, the less pressure. There is more oxygen on the Earth due to the atmospheric pressure being higher than the pressure away from Earth. As we go to higher altitudes, the pressure in the air drops and hence the oxygen level drops. Let's have a demonstration on how pressure is involved. The experiment is called the Cartesian diver. For this, you'll need a clay, a plastic bottle, a bendy straw, the longer part must be shortened, and a water to fill the bottle. First, put a piece of clay in the shorter end of the straw enough to seal. The excess can be wrapped around the straw. Next, fill the plastic bottle completely with water. Drop the bendy straw with clay inside the plastic bottle. Note that the straw must float. You may need to adjust the length of the straw, and the amount of clay so the diver will float. Place the lid of the plastic bottle tightly. Now let's see what will happen to the straw with clay. Press the bottle. While doing this, observe the movement of the object inside the bottle, which is floating. It sinks down as you press the bottle. When you release the bottle, it floats up again. How does it work? The straw contains an air bubbles confined. The combined density of the straw, air and clay is slightly lower than that of the water, so it floats. When you squeeze the sides of the bottle, you increase the pressure pushing on the air bubbles, making it compress into a smaller space. This decrease in volume causes the air bubbles to increase in density. Therefore, the total density of the straw will now be greater than that of the surrounding water, making it sink. Releasing the pressure on the bottle allows the air bubble to expand back to its normal size, and so the straw diver will float again. This experiment is related to Pascal's law. It states that pressure exerted anywhere in a confined incompressible fluid is transmitted equally in all directions throughout the fluid, such that the pressure variations remain the same. Pascal's law is named after the French mathematician Blaise Pascal. This is also applied in hydraulics. Hydraulic lift, for lifting heavy objects. Hydraulic brakes, used in vehicles. Have some practice, you may try these problems. The answers are available to check your work. Thank you for watching DEMOPHYSICS.